Jai Hind everyone. I Prashant Tripathi, Assistant Professor in Electronics and in Communication Engineering Department at Ajay Kumar Garg Engineering College, going to present a complex topic, a spread spectrum modulation technique in wireless and mobile communication. The content of this presentation are spread spectrum modulation, pseudo-noise codes with properties and code generation, direct sequence spread spectrum and frequency hopping spread spectrum system, time hopping and hybrid spread system. So, before I start this topic, first of all, I would like to tell that this spread spectrum modulation technique was initially established for military and intelligence purpose to combat the interference and jamming signal, but due to its virtues like multiple access technique, multipath mitigation, flexibility and robustness, these techniques are widely used in civilian application. In spread spectrum modulation technique, the signal, whether it is electrical, electromagnetic or acoustic, which is generated with a particular bandwidth, is deliberately spread in frequency domain, and the resulting signal have a wider bandwidth. So, in spread spectrum modulation technique, we spread the bandwidth of the original baseband signal. To achieve this task, the spread spectrum modulation technique add some redundancies in the original spectrum. Suppose we have a signal with bandwidth B, then the spread spectrum technique expand its bandwidth in such a way that the output or spread spectrum signal bandwidth BSS must be greater than this original signal bandwidth. So, our purpose in spread spectrum modulation technique is to enhance the spectrum of original signal. Here, this diagram shows that how can we enhance the spectrum of original baseband signal. The spreading task is accomplished with a spreading code which is shown here. This is the spreading process in which the bandwidth of original signal is B and it is basically multiplied with a spreading code, and the resultant signal bandwidth is much higher than the original baseband signal bandwidth, that is BSS must be greater than B. This is the basic concept of spread spectrum modulation technique. The spreading code plays an important role in spreading the spectrum of original baseband signal. The spreading code, as I told you, is very important in spread spectrum technique, and this code is also known as pseudo-noise code. So, we are going to discuss the pseudo-noise code and its properties and how they are generated. So, pseudo-noise code are also popularly known as PN codes, PN sequence or PN chips. The PN code or PN sequence is basically a binary periodic sequence with a noise like waveform, and it is generated by a feedback shift register, as I have demonstrated this circuit in figure 2. This is the feedback shift register in which the feedback to first flip-flop is provided by a logic circuit. This logic circuit computes a Boolean expression with the state of flip-flops, and the output of this logic circuit is feedback to first flip-flop. All the flip-flop in this feedback shift register are governed by a single clock. At each clock pulse, the state of one flip-flop is shift next on the line to next flip-flop, and at each clock the logic circuit compute a Boolean expression based on the states of flip-flop, and the output of this logic circuit is fed into first flip-flop. Here we get an output which is basically our PN sequence. The length of PN sequence is determined by the length of shift register, initial state, and feedback logic. The feedback logic basically represent the Boolean expression which we use to compute the input of first flip-flop in feedback shift register. Mostly the PN code is represented by a binary string of ones and zeros, and these ones and zeros are represented by polar signaling. If it has some properties like a good PN sequence is characterized by an autocorrelation that is similar to a white noise, or which has only two values, as I will show you in next slide. Apart from this, the autocorrelation function of PN sequence is high at tau equals to 0 and low for other values. For example, for tau not equal to 0, the autocorrelation function must have small values. The bit rate of a PN code is known as chip rate, which is defined by 1 by T chip, which is 10 times more than the data bit rate. And as I told you that this PN code is mainly responsible for spreading the signal, spreading the spectrum of given signal. The smallest time increment in the sequence of a certain period or duration is represented by T chip, and it is known as time chip. The total period of a PN sequence consists of NC time chips, and this chip rate is important as it decides the final transmission spectrum of direct sequence spread spectrum modulation technique. In practically, there are several spreading codes which are used for spreading the spectrum. Some of them are maximum sequence length code, Gold code, Kasmi code, and Barker code. Out of these codes, the maximum sequence length code are popular, and the longest code that can be generated by simply a feedback shift register of a specific length. Suppose we have an L stage shift register and few XR gate. So in this shift register we can generate a sequence of length 2 raised to the power L minus 1. After this duration, the given PN sequence will repeat itself. That is, it will become periodic. the maximum, now we are going to discuss the maximum length pseudo random code generator. As I told you that this maximum length pseudo random code generator is derived from a feedback shift register which has simply flip flop which are connected with a single clock signal. Here in this figure I have shown a maximum length sequence generator. In this feedback shift register we are using n flip flops and all the flip flops are connected with a single clock signal. These flip flops are basically memory element and store the bit until the next clock arrives. The logical circuit is simply a modulo 2 adder which take states from the flip flops. Like in this figure, the logic circuit take the output from n minus 2 flip flop and the output flip flop, and it's compute the logical expression, and output of this logical expression is again feedback into the first flip flop. In such a way, at each clock pulse we get an output, and this sequence of output is known as PN sequence, yes, or pseudo random code. Now the pseudo random code has some properties, like if we take a period, then in a period the number of ones is always 1 greater than number of zeros. For example, if we take n equals to 8, there will be 128 ones and 127 zeros in one complete cycle of the sequence. Here I have shown the autocorrelation of a pseudo noise sequence. As I told you that the autocorrelation function of a PN sequence is similar to white noise, and it has only two values, and these two values are 1 and minus 1 by n, as it is shown in this figure. And also it is noticeable that at tau equals to 0, the value of this autocorrelation function is high, but at other instances the value of this autocorrelation function is decreasing. For other cases its value is minus 1 by n. So it is very important to decide a correct PN signal for spreading the original spectrum of baseband signal, and if we decide it correctly, then our resultant spectrum will fulfill our desire. Here the two autocorrelation and cross correlation equations are also provided. Using these two equations we compute this autocorrelation function. Now we come to classification of spread spectrum system. There are two types of spread spectrum system. One is known as averaging system and second is known as avoidance system. These classifications are based on how our system is going to deal the interference or jamming signal which the enemy or any intruder going to insert in our system. In averaging system, the interference reduction take place because the interference can be averaged over a large time interval. So, in this averaging system, the interference is reduced by integrating the interference over a long time interval, and its example is direct sequence spread spectrum. While in avoidance system, the signal is avoided from interference for a large fraction of time. The example of avoidance system are frequency hopping, time hopping, and chirping system. Now, we are going to discuss direct sequence spread spectrum. In direct sequence spread spectrum, the spectrum of original signal is also expanded, but the process is entirely different. In direct sequence spread spectrum, each bit is replaced with n bits of a PN sequence. Whenever a user wants to send data using direct sequence spread spectrum technique, each bit of user data is multiplied by a secret code or chipping code, which is basically a PN sequence, pseudo noise sequence. This chipping code or pseudo noise code, when multiplied with the original signal, it divides the bits into small intervals, and this multiplied signal is used as a direct sequence spread spectrum. At the receiver side, the receiver uses the same code to extract the original message from the received signal. Here, the working of direct sequence spread spectrum is shown in figure. This is simply a multiplier in which the original signal and chip generator, which is a PN code, is multiplied, and the resultant of this multiplication is a spread spectrum signal. Here, the red line represents the original signal and the black one represents the PN sequence. As I told you that this PN sequence is periodic, so this is represented here. This sequence repeats after a certain bits. In PN sequence, the duration of one bit is very small. When we multiply both of these signal, we get a chopped version of original signal, and this chopped version is the spread spectrum modulated signal. Why? The question arises, why this is spread spectrum signal? So, as we are observing that in this spreading code, the width of a bit is very small, so its spectrum will be broad. Here, the duration of a single bit is large, so if we find its spectrum will be narrow, because there is an inverse relationship between time and frequency. So, when we multiply two time domain signal in frequency domain, they get convolved, and if we convolve two signal which has different spectrum bandwidth, then the resultant spectrum will obviously broader. So, due to this time domain multiplication, we get a convolution in frequency domain, and this convolution results a wider spectrum against the original signal. Here, the PN sequence which we are using has 11 chips, 1 0 1 1 0 1 1 1 0 0 0. After this sequence, it is repeating itself, as I told you earlier. So, using just this simple multiplication with a PN sequence, we can easily obtain the direct sequence spread spectrum technique. In this, I have shown the transmitter and receiver for direct sequence spread spectrum. In this system is used for long distance transmission. So, we have also used a radio carrier which is modulated using spread spectrum signal, and after modulation we transmit this radio signal at longer distances. So, the simple process is we take the user data and multiply this data with the PN sequence, chopping sequence. The resultant signal will be spread spectrum signal, and this spread spectrum signal is used to further modulate a radio carrier, and using this modulation we get a spread spectrum modulated signal which is transmitted to the long distances. At receiver side, we received this signal, and first we demodulate the received signal, and after demodulating we pass the demodulated signal with a low pass filter, and this low pass filtered signal is multiplied with a PN sequence that we have used at the receiver side, and the product is integrated. After the integration, we get the integrated values, and the value is compared with a decision device. If in decision device we set a threshold, if the value of integration is greater than threshold, a decision is made in favor of symbol 1, and if the value is small or fall below the threshold, a decision is made in favor of symbol 0. So, this is the basic working of direct sequence spread spectrum technique. The next one is frequency hopping spread spectrum technique. The frequency hopping spread spectrum technique, in this technique, the carrier frequency is continuously changing. As the name suggests, the frequency is hopping from one frequency to another frequency. Basically, this technique utilizes m different carrier frequencies to transmit our desired signal. At a particular instant of time, the baseband signal modulates only one carrier frequency, and at the next moment the signal modulates another carrier frequency. Also, in this modulation technique, the bandwidth is very much greater than the original signal bandwidth. In this figure, we have shown the concept of frequency hopping spread spectrum technique. This columns represent the frequencies, how frequencies are jumping from one frequency to another frequency. For a particular instant of time, the frequency is this, but at the next time, it is clearly visualized that the frequency is changed. So, in frequency hopping, we continuously change the carrier frequency so that the interferer or jamming signal can't predict our frequency of transmission, and we can easily save our desired signal from the intruder or enemy. The basic generation of frequency hop spread spectrum is shown in this figure. In frequency hop spread spectrum technique, we use the PN sequence generator, and which is used to drive a frequency synthesizer. A frequency synthesizer generates different frequency, and this frequency synthesizer is governed by this pseudo random code generator. The frequency table is used the pattern to fill the frequency to be used for the hopping and passes it to the frequency synthesizer. The frequency synthesizer creates a carrier signal of that frequency and the source signal modulate the carrier signal. The same thing is shown in this figure. For a particular PN sequence, this frequency synthesizer generates a carrier frequency which is further modulated by the original signal. As we change the bits in PN sequence, the frequency gets changed and we have a new modulated signal which has an entirely different carrier frequency. For example, as it is shown in this table, for 101 the carrier frequency is 700 kilohertz, but for 111 the carrier frequency is 900 kilohertz. So for each of these bit sequence, the frequency table has a different carrier frequency, and the value of, according to value of these PN sequences, the carrier is selected and this carrier is modulated by the baseband signal. Now, if the benefit of frequency hop spread spectrum is that, suppose if the introducer trace our carrier frequency and after knowing the carrier frequency, he tried to send the same frequency from their end, when the signal sent by the enemy will reach in frequency hop spread spectrum, the desired frequency has already changed from the previous one. So it provides the protection against a smart jammer. This is the basic advantage of frequency hop spread spectrum technique. This is the frequency hop spread spectrum transmitter and receiver diagram, in which the bit is going to modulate, as I told you, a carrier frequency which is selected by this PN code generator. According to PN code generator, different carrier frequencies are selected which are further modulated by the baseband signal, and after modulation these frequencies are transmitted to the receiver side. At receiver side, the same PN code is used to derive the original baseband signal from the received signal. Generally, in frequency hop spread spectrum, we use binary phase shift keying modulation for the transmission of signal to long distance. A time frequency plane shows the different frequency hopping operation. For example, we have 8 codes, and for this the carrier frequency is 8 kilohertz. As we can see that for 000 the output frequency is 9.75. The frequency is shown here. For 001 the frequency is 9.25. So for different PN sequence combination, we have different frequency, and it is clearly visualized from this figure that our frequency jump from 9.75 kilohertz to 6.25 kilohertz. So, we can't predict, our enemy can't predict that we are transmitting signal in which particular frequency range. The next spread spectrum is time hopping spread spectrum. In time hopping spread spectrum, the data is transmitted in a sequence of short pulses at different time instants, and these time instants are decided by a PN sequence. In time hopping spread spectrum, entire time axis is divided into small intervals, and these intervals are known as frame. Further, the frames are divided into M slots, and the baseband signal modulates any one time slot. For example, in this time frame, the baseband signal modulates this particular time slot. After modulating, all the modulated time slot are gathered and it is transmitted as a burst in the next transmitted sequence. And again, in this time hopping spread spectrum, the PN sequence decide which time slot is used for modulation. This is the basic receiver of time hopping spread spectrum, in which the PN code generator with the help of AND gate drives this on off switch, and we use the demodulation unit to remove the modulation which we have applied at the transmitter side. And as we are using the time sequence, so there is a provision to for bit synchronization. To use this bit synchronization, we use bit synchronizer, and storing and retiming devices is used for generating the original message signal from the transmitted signal. Now, in this table, we have compared the existing spread spectrum modulation technique, in which direct sequence spread spectrum, frequency hop spread spectrum, time hop spread spectrum techniques are compared. In direct sequence spread spectrum technique, the single carrier system is used for all time, but in frequency hop spread spectrum technique, different hopping carrier frequency is chosen. But in time hopping spread spectrum technique, a single carrier is transmitted but at different time. Direct sequence spread spectrum method is simply to implement. Frequency hop is complex, and time hop spread spectrum technique is simpler than frequency hop spread spectrum technique. The direct sequence spread spectrum method suffer from near for problem, but frequency hop spread spectrum technique and time hop spread spectrum technique avoid near for problem. So, these are the different comparison on which we can select the spread spectrum technique according to our applications. In many applications, we can't use only a single spread spectrum technique to fulfill our requirement. So, as I told you that direct sequence spread spectrum technique suffers from near for problem. So, so some kind of power control must be provided to avoid this near far effect, and this provision make the system more complex and inexpensive. So, in many applications, we integrate the direct sequence spread spectrum technique with frequency hop spread spectrum technique to fulfill our desired applications. Now, I am going to discuss the advantages of spread spectrum over the fixed frequency transmission. There are mainly three advantages of spread spectrum technique. The first is the signal become more resistant to noise and interference. The second advantage is the spread spectrum signals are difficult to interpret. Third and important advantage is using spread spectrum technique, if particular frequency band can be shared with many users or sources. This is the major advantage of spread spectrum technique. The popular application of spread spectrum technique is code division multiple access. In code division multiple access technique, multiple user utilizes the same communication channel or bandwidth with a effective manner. Also, the code division multiple access, when multiple users are utilizing the same communication resource, same communication channel, there is a possibility of interference. But by using control on the transmitted power and orthogonal codes which are derived from the Walsh table, we can easily use the code division multiple access for digital cellular telephony. So, these are the popular applications of spread spectrum modulation technique. These are the two references which I have used while making this presentation. Thank you.